So let us see how to do the calculation part, how to find out this tension developed in the strings analytically, as a point P is in a space. Okay, so and all the forces are meeting at point P. So here we can say this is the point of concurrency and this is the concurrent force system, as we have discussed. So here let us say the coordinate of this point P as xp, yp, zp. Similarly, the coordinate of point 1 as x1, y1, z1. Coordinate of point 2 as x2, y2, z2, and this is the point 3 which coordinates are x3, y3, z3. So here I am showing the sample calculation for observation number 1. So here the coordinates of this point 1 are 0.15, 0, 0. The coordinate of point 2 as 0.6, 0.3 and 0. Coordinate of point 3 are 0.15, 0.6 and 0, and the coordinate of this point P are 0.36, 0.28 and minus 0.48. Here I am showing minus because I considered the positive x-axis in the upward direction. Okay, so as we have discussed how to find out the unit vector along any given line. So here we are considering along this line the unit vector as E1, over here the unit vector as E2, and here the unit vector as E3 over here. So E1, when I have to calculate unit vector along the line P21, so here I have to use this relation as x1 minus xp, as we are considering the force is acting from P to point 1. So x1 minus xpi plus y1 minus ypj plus z1 minus zpk divided by under root x1 minus xp square plus y1 minus yp square plus z1 minus zp square. So in this way we can calculate the unit vector along the line. So let us put the respective values over here. So E1, we have x1 is 0.15, yp is over here for this point is 0.36, this is I, plus y1 is 0 minus 0.28 j plus here 0 minus, now that zp coordinate is minus, I am writing minus of 0.8 k, and this is divided by under root of that quantity. So that is your 0.15 minus 0.36 square plus 0 minus 0.28 square plus here 0 plus 0.48 square. So if I calculate the value of this under root, so I am getting here, and after subtracting these values, so E1 vector as minus 0.21i minus 0.28j, 0 minus of point, that is your plus 0.48k divided by, after doing the subtraction and calculating the square root of this, I am getting the value as 0.594. Okay, so I will divide all this expression by 0.594. So after dividing by 0.594 to this quantity, I am getting E1 vector is equals to minus 0.353i minus 0.471j plus 0.808k. So this is our unit vector So this is the unit vector what we calculate for the tension which is passing from point P to point 1. Similarly, we will calculate the unit vector along the lines passing through point P to point 2 and from point P to point 3. Okay, that is E1 and E2. So in the same way, we will calculate the unit vector for this tension T2 which is acting from point P to point 2. Hence, while calculating the unit vector along this line, we have to subtract the coordinate of point 2, okay, minus the coordinate of point P. Similarly, for coordinate of point 3 minus coordinate of point P to calculate E3 unit vector. Okay, so now we will calculate that E2 vector. So to calculate the E2 vector, we have to do 0.6 minus 0.36i, that is x2 minus xp, okay, plus 0.3 minus 0.28j plus 0 minus of 0.48 K divided by the magnitude of this quantity. So that is 0.6 minus 0.36 square plus 0.3 minus 0.28 square plus 0.48 square. Directly I am writing minus get plus. Okay. So here after doing the calculation, we get the relation as 0.24i plus 0.02j plus 0.48k. Okay, that is 0.6 minus 0.36, we are getting 0.24. Okay, 0.3 minus 0.28, we are getting 0.02. Okay, so similarly we are calculating the all the quantities. Okay, and divided by the value of this under root is coming 0.537. So after dividing by 0.537 to this quantity, we are getting the unit vector along that direction as 0.447i plus 0.037j plus 0.893k. So in this way we are getting the unit vector along that line. Now similarly we will calculate the unit vector along the third line, that is E3. So to that, again coordinate of point 3 minus coordinate of that point P. So we have for this 0.15 minus 0.36i plus 0.6 minus 0.28j plus 0 minus of 0.48k divided by the magnitude of this quantity. And we know how to find out the magnitude of this equation. Okay, so here 0.15 minus 0.36 square plus 0.6 minus 0.28 square plus 0.48 square. So after doing the calculation, we are getting the unit vector along that direction as minus 0.342i plus 0.521j plus 0.781k. So this is our unit vector which is passing through point P to point 3. So in this way we have calculated the unit vector for observation number 1. Okay. So as we have discussed in the theory, we know that when we have to express the force vector, so here force vector is nothing but the tension developed in the string, so that force vector T1, okay, T1 vector, we can write it as T1 into unit vector along that direction, and unit vector along that direction what we considered as E1. Okay, so T1 into E1. So I will put the respective values and now I will get the relation. Now here this don't put the value of T1 what we get experimentally. Here we have to calculate this T1 analytically. So T1 into what is our E1 vector? E1 vector, what we calculate the E1 vector as minus 0.353I minus 0.471J plus 0.808K. So we will write this unit vector here. So that is minus 0.353I minus 0.471J plus 0.808K. Okay, so we are getting the relation as after multiplying this T1. So minus 0.353 T1I minus 0.471 T1J plus 0.808 T1K. So similarly we will write the force vector for T2 as T2 into unit vector along that direction. So for T2 we have considered unit vector as E2. Okay, so here after putting the value of this E2 we are getting T2 vector as 0.447 T2I plus 0.037 T2J plus 0.893 T2K. So in the same way I will write the relation for the force vector, okay, T3. So T3 vector is equals to T3 into unit vector is E3. Okay, so for this we have the relation as minus 0.342 T3I plus 0.521 T3J plus 0.781 T3K. Okay, and the last relation for that W which is acting along the Z direction. So W vector is equals to minus W into K, because along that it is K. So let us say this is our equation number 1. This is equation number 2. Here is equation 3, and the value of I'll put the value of this W which is 10 for that. So minus 10 into K. So let us say this is your equation 4. Now we have this 4 relation with us. As the given system is in equilibrium, so we will apply the conditions of equilibrium. Now here we will apply the conditions of equilibrium for this force system. So first I have summation f of x is equals to 0. What is the meaning of this? Summation f of x is equals to 0. That means the x component of all that force vector. So what are the x component over here? X component is nothing but the coefficient of this I. because I is the unit vector which is acting along x direction. Okay, so here I will take the coefficient of this I, that is minus 0.353. Okay, so for T2 vector, the x component of that force is 0.447. Okay, so in the same way I will take the coefficient of this for force T3 as minus 0.342 as the x component of that. So summation f of x is equals to 0. So what I am getting over here, minus 0.353 T1. Okay, what is for second is 0.447 T2. So plus 0.447 T2, and for T3 vector it is minus 0.342 T3. Here there is no x component, okay, is equals to 0. So let us say this is our equation number 5. So now we will go for second condition of equilibrium, that is summation f of y is equals to 0. What is the meaning of that? Y component of that forces. So what are the y component over here? The coefficient of your j unit vector. Okay, so I will do the addition of all that y component over here. So minus 0.471 T1 plus 0.037 T2 plus 0.521 T3 is equals to 0. So now we are saying this is our equation number 6. Similarly, we will go for the next condition of equilibrium, which is summation f of z is equals to 0. That means what it is? The component of that force is acting along z direction. That is the coefficient of k. So what the coefficient of k we have over here? For T1 it is 0.808. Okay, for T2 vector 0.893. For T3 vector for T3 vector 0.781, and for W as it is acting along your z axis, so here minus 10. So here we have 0.808 T1 plus 0.893 T2 plus 0.781 T3. Okay, so minus 10 is equals to 0. So I will rewrite this, minus 808 T1 plus 0.893 T2 plus 0.781 T3. Now I will take this minus 10 on the right hand side, so it will become your plus 10, and now we are saying this is our equation number 7. So now we have three equations. This is our first equation, okay, where unknowns are T1, T2, T3. In the second equation, unknowns are T1, T2, T3, and in the third equation, unknowns are T1, T2, T3, and we have one. So after solving these three equations, we are getting the values of T1 as 3.716 Newton, T2 as 5.221 Newton, and T3 we are getting 2.989. So nearly I considered this is equals to our 3 Newton. So in this way we are getting these values analytically. Next we have to calculate the percentage error. Okay, we have to calculate the percentage error over here. Okay, so how do we calculate the percentage error over here? That is analytical value minus experimental value divided by analytical value into 100. Okay, so we will calculate percentage error for T1 as percentage error for T1. Okay, what is the analytical value we have over here? That is 3.716. Experimental value we have 4, so minus 4. Okay, divided by the analytical value is 3.716. We will take the mod of this, multiplied by 100. So after doing the calculation, we are getting 7.6 percentage. Okay, so we have an error of 7.6% for T1 value. So similarly, we will calculate the percentage error for T2. Okay, so for T2 we have the mod of 5.221 minus experimental value we have 4.75, mod of this divided by analytical value is 5.221 multiplied by 100. So after doing the calculation, we are getting 9.02%. And last, we will calculate the percentage error for T3, okay, which is equals to 3 minus 3.75. This is our experimental value, and analytical we got 3 divided by 3 into 100. Okay, so here we are getting 25% error over here. So in this way we can calculate these tensions T1, T2, T3, okay, analytically. So here we got the values of T1, T2, T3 analytically, and hence we have calculated also the percentage error. So in the similar way, you have to calculate the tensions for the remaining observations. Okay, thank you so much.